Hi, this is Martin Fowler, and you're listening to the Agile Uprising.
Hello, everyone, and welcome to another edition of the Agile Uprising podcast. I am your host, Troy Lightfoot, and with me, I have a very special guest, co-founder. Hopefully, I'm saying this correctly. Co-founder of ProKanban.org, Prateek Singh.
Yeah, it's not exactly co-founder, but I came in pretty early.
Oh, okay. Yeah, well, fair enough. Fair enough. Okay.
Yeah. But that's cool. I'll take it.
Do you have a title?
Sorry. Yeah, sorry. I'll take the co-founder as well. No.
Oh, I see.
Yeah, I'm the head of training and development, head of learning and development at ProKanban.org.
Okay, very good. And Prateek is someone that I have worked with as a trainer for ProKanban.org, obviously, and he also has written some fantastic blog posts. Especially one of them I'm going to link out, which is relevant to the topic today about Monte Carlo. And in fact, in one of the most recent episodes that I recorded, I used a Google sheet to explain how WIP impacts priority. And that Google sheet I credited to you, and now you're on the podcast. So there we go. All right. So it's all coming full circle. So I got him on the podcast, folks, is what I'm saying. And he also has a fantastic YouTube channel called Drunk Agile, where at the beginning, the premise is basically at the beginning of each episode, they're drinking. And him and Dan Vicanti, and they are just talking about different topics, right? And they have many episodes on this topic, but I have kind of curated an outline which is specific to what I think our audience would be interested in. So thank you, Prateek, for joining.
No problem. No, it's happy to be here. It's great.
All right, excellent. Well, today, Prateek, you have been asked to come on to talk about probabilistic forecasting, and in particular, a method for that called Monte Carlo. So I would love to know, Prateek, what the heck is probabilistic forecasting, and why do we need it? What problem are we trying to solve?
Yeah, I think that's first of all, that is the key question to answer before we get into any of the maths that we're going to get into.
Right.
The why probabilistic forecasting? Why even have a probabilistic worldview? Traditionally, as we grow up, as we learn things, we have a very deterministic worldview. Your question answers that you see on your exams are multiple choice, or there's just this one answer. There isn't a range of answers. But it turns out, when you look around the world, when you're trying to figure out what will happen, there are always multiple things that can happen. And each of those has a probability of happening, a chance of happening. In order to forecast the future, in order to attempt to tell the future, we cannot necessarily say this is exactly what will happen. We are better off saying things like there's an X percentage chance that A will happen, or X percentage chance that B would happen.
Right.
So, for example, when your favorite sports team is playing their rivals, you won't say that team A is going to win. You'll probably say there's an X percentage chance that team A is going to win and a Y percentage chance that team B is going to win.
I see.
That is probabilistic. Yeah.
Do you know how they calculate that for sports games?
So the bookies, they set the odds, and that's again, you go to the odds. And I'm not sure about how the bookies go about setting the odds. What I do know is if you're in the middle of a game right now, or if a game is going on right now, and you go to most sports websites, they will give you a percentage chance of A happening, or B happening, or C, whatever the number of results are. And usually they are doing something very similar to what we are going to be talking about today.
Oh, wow. Okay.
They're usually running Spoiler alert, they're running Monte Carlo simulations.
Right. One of the biggest, so I was talking about this to a colleague of mine at work a couple weeks ago, and my wife overheard me continuously using the word Monte Carlo because I was talking about doing it at a current client I'm at. And we went out to dinner on the weekend, and she goes, we're at dinner, and we're just having a normal conversation, and she stops me and she goes, "What's Monte Carlo?" Right. And I said, "Really? We got to talk about this at dinner?" So she's like, "Yeah, I want to know. You talking to your coworker about it? It sounds interesting." So I explained it to her, and she was kind of getting it, I think. And then I said something which I think made her stop and was a big revelation for her about probabilistic forecasting. And basically what I said was that the weather forecast is never wrong. And she didn't understand. At first, she didn't understand what I meant by that. And I'm like, well, okay, so it's going to rain, for example, and they're saying there's a 30% chance of it raining in your area, or a 70% chance of it raining in your area, right? So I said, whether it rains or not in your area, they're not wrong.
Yeah.
It took her a little while to understand that, but I'm like, well, 70% of the time in their simulations, right, it came out that it rained 30% in the area. 30% of the time it didn't. There's a 30% chance it won't, rain in your area. So therefore, they're not wrong either way. And that was like kind of like, oh, like that. She kind of got it when she understood that. Like, it's a probability. It's not an exact answer.
So, yeah. So for your listeners, if you never want to be wrong about your forecasts, use probabilistic forecasting.
There you go. There you go. Right. So what are some of the advantages of using probabilistic forecasting over deterministic forecasting?
Probably the greatest advantage is the fact that what you already said, you're never going to be wrong. Right. But at the same time, what you're able to do is you're able to communicate not just answers of things like when will it be done or what will be done. You're also able to communicate the risk associated with that forecast. Just as you said, there's a 30% chance of rain. Well, you're not just saying whether it will rain or not. What you're saying is the good chance will rain, and the risk of rain today is 30%. So then it's, for example, saying things like, we're going to get done recording this podcast in 20 minutes from now. Right. There's about an 80% chance that will happen.
Right. Right.
Able to associate risk with it. Yeah.
Right. Yeah. So from what I hear you saying, it talks about your forecast in terms of level of risk, and what you do with that information is up to you. But that information is something we wouldn't get typically from a deterministic forecast. Mm-hmm. And so, for example, if you were planning an outdoor wedding, right? And somebody said, okay, the weather's saying that on your wedding day, there's a 80% chance it's going to rain in your area, right? What do you do with that information? Do you still just plan for it outside? Do you buy a tent? Do you move it inside, right? Just presenting information to be able to make a determination. Funny thing is, I was teaching an AMP class this week. We can link it in the description later, what AMP is, but it's a flow metrics and probabilistic forecasting class offered by ProComma.org. So I'm teaching that, and a lot of the students were selecting 95% for everything. And they want to be like the most certain they can be, And I was trying to get them to realize that you can do that, but you're making a huge trade-off by doing that. And that I said, okay, so you don't want to pick 85%. Let me make this, let me come up with a scenario. So I'm going to give you $20, and you're going to take that $20 and buy a lottery ticket, okay? And I'm going to tell you that I'm going to run the simulations, and that you have an 85% probability of winning the lottery with that $20, and it's going to equal $20,000. Okay. And you have an 85% probability. How are you feeling about it? Are you excited? Right? How come? Yeah. Right? Like, you're probably feeling really good about those odds, right? But yeah, it's funny when we're asked to give a forecast with an 85th percentile. Some people are really nervous about that, right? Because they're nervous even about the 15% risk, right? So it's kind of a perspective of how we perceive it in a way.
Yeah, and that, 85% has somehow become very normal for people to talk about. But you're absolutely right. It could go to the 95th, could go to 70%, could go to 50%. It's a question of how much risk are you willing to take. And as you were saying, Troy, that information gets hidden when you do a deterministic forecast. This is the date. You have no idea what the risk is. Yeah.
So before we get to Monte Carlo, what would be an example of a deterministic forecast in the Agile world?
Ooh, there's so many. There's so many, and they're around everywhere. It's things like saying we are going to get. I'll ask your audience to cover their ears for a little bit. We are going to get 20 story points done in this 2-week sprint.
Yeah,
that's a deterministic forecast. Or this project that we have gone ahead and estimated out to be 30 stories, it is going to get done by the end of this month, or at the end of this month. That is interestingly, that little difference by the end of this month makes it more of a range, but at the end of this month is the deterministic forecast.
Right. Yeah. And most times when people communicate that, especially if they're communicating it to a stakeholder, to their boss, to a customer, typically it's in the form of a single date. I mean, it doesn't have to be, of course, but often it will be, hey, we're going to have a release on July 13th, or we're going to something like that. Right. Yeah. Gotcha. Okay. And it's the assumption from the other person's perspective is often that the scope is going to be fixed for that release. Right. Yeah. That is the assumption that you're thinking when you're giving that date. Right.
Yeah.
You may not
there
be
are
thinking
30
that.
things.
Right.
Yeah, exactly. We said there are 30 things. They're going to be done on this date. Yeah.
Right. And that is a deterministic answer. Right. Okay, cool. So let's talk about what are some of the, before we get specifically to Monte Carlo, in other industries besides software development, right? How is probabilistic forecasting used? Like, what are the use cases outside of software development?
Yeah. As a hint, and you all will look around and see this. I'm hoping after this listening to this podcast, you'll see this everywhere. Anytime you see a range, which is saying by this time or by this date or whatever, and an associated probability, that's a probabilistic forecast.
Right.
A great example of this is when you're driving somewhere. If you're using something like Waze or Google Maps, they'll tell you you're going to get to your destination in the next 20 minutes, sometime in the next 20 minutes, and then they'll have a color on it. It'll be green or yellow or red. And that's kind of showing both how much traffic there is in your way and how very probable or less probable it is that forecast is going to hold. Because the traffic might clear up and that might change immediately. So you're getting this range and probability that you will also see as you keep driving. That number keeps changing. It keeps reforecasting. That's something that hopefully everyone's familiar with. I live in South Florida. I live on the eastern seaboard of the United States, and the place we see probabilistic forecasting almost all the time, especially right now, it's July, we are in hurricane season. We see hurricane forecasts all the time. And those of you who aren't familiar with it, it's a cone, and they show like this cone of probability sort of thing. And it's the cone of destruction. And it's a range that this is where the hurricane can go. And there's a probability of that range, which I will leave that as homework for people to look up. What is the probability of that range of the hurricane cone? Yeah.
All right. So you have some homework out there. If you want to know more about hurricanes and probabilities and how it relates to software development, you can do one of two things. You can attend an AM class or you can watch Dan Vicanti's talk on YouTube, which I'll link, which is called Your Project Behaves Like a Hurricane. Both of those things are an appropriate thing to do. So I will make sure to link that. All right. Thank you. So let's talk about a technique that we use in software development, but didn't start in software development. We're just utilizing the technique. And that technique is called Monte Carlo or the Monte Carlo method. So Prateek, why don't you tell us a little bit about the history and what it is?
Yeah, the history is actually kind of, I find it super interesting. It didn't lead to great things, but it was super interesting for me. Um, during the World Wars, when we were trying to figure out how to start a nuclear reaction so that we could have an atom bomb, a nuclear bomb. And what you do is you fire neutrons through a uranium atom to start the reaction.
Mhm.
But you have no idea how many particles you need to fire through to start it. There is absolutely there's no science that you can really apply to it just because of science, because
Right.
because of the Heisenberg principle, because of the
Right.
fact that these things, you can only know the position or the velocity of these things. So the way that they figured out how to do it was to just run a whole bunch of simulations, and they actually did this by hand, and uh, figure out what amount of particles give a high probability of starting the reaction.
Hmm.
And that is where they came up with this thing called Monte Carlo, because it sounded like gambling. There was
Right.
not a sure number
Okay.
to a math person, to a science person's head. That's gambling. And
Hmm.
Monte Carlo Casino was one of the biggest things around, so that
Right.
started like gambling, and that's how they came up with this thing called Monte Carlo simulations.
I actually read it's hard to know exactly what's true online sometimes, right? But I actually read something about the history of Monte Carlo, and that there was a white paper originally written by, I don't, maybe I should memorize this guy's name actually, but anyway, white paper written by a mathematician or a scientist, one of the two, who was laid up for 3 months after a leg surgery, and he was trying to figure out the probability of the odds of winning a game of solitaire because he kept playing these games by himself. And he wrote a white paper on basically an algorithm that he created by hand. And that initial work was used for this Manhattan Project. I don't know if I'm not sure if you had heard of that before, but
Yeah, I believe those are those are related stories. Those are absolutely
okay,
related stories. And
I see.
one of the I don't think it was Enrico Fermi, but it was one of the scientists who was on the Manhattan Project. His uncle, I think, wrote that paper or something.
Oh wow,
And
okay, I see. Gotcha.
there is, again, we're
Yeah.
going into mythical land here. We don't have an idea, but
Right.
yeah, that's what I remember as a starting point for this. Yes,
Okay.
and again, it's gambling. It sounds like gambling. That's what.
Sure, sure.
Yeah.
So one of the interesting things about gambling, right, and probabilities is there's a term called the gambler's fallacy. And there's other terms for it too. But the idea is that human beings are very good, actually, at pattern recognition. And sometimes that, for our survival, that's very beneficial. But on other times, it can get us in trouble, especially when it comes to gambling, right? So there's something out there called the law of large numbers. And the law of large numbers basically states that, and I could be butchering it, but it basically states that the closer you get to infinity, the closer you get to zero, or the more times you do something, the closer you get to the actual probability of something happening, right? And casinos know this very well, and they utilize this to their advantage. And one of the ways they do it is by always weighting the odds at least slightly in their favor, because they know that in the short term, for example, let's take a roulette wheel. There is a reason why there's, in some countries, there's only, from what I read, there's only one green square or space on a roulette wheel. And in the US, there's two. And the reason for that is because when you bet on red or black, you're betting on a 50-50, actually. And it is not a 50-50.
Yeah.
And because they have weighted it slightly against you. And in the short term, you could win 9 out of 10 times or whatever, 10 out of 10 times, actually, right? But if you spin that roulette wheel a million times, you will always lose your money based on that, based on the odds, basically, if you keep betting a single way. So they're applying this idea of law of large numbers, basically saying, we're just going to keep doing something thousands of times, millions of times, And over time, because we have the bankroll to support losing in the short term, that we will always win. And that's where they come up with this thing, the house always wins, right? So
yeah, it's on the roulette wheel, I think it's like 46.7% that you'll get red or black. And
right.
yeah, you're betting 50-50. Yeah.
Yeah, so that they're applying the law of large numbers to that roulette wheel, basically. And so that's a lead-in for the Monte Carlo. All right, so why don't you tell us about, okay, so we learned about the history of where it comes from. So what is it exactly?
Yeah, so Monte Carlo, in its simplest form, a Monte Carlo method is, or let's start with Monte Carlo simulation. A Monte Carlo simulation is saying, knowing what we know now, how can we run a simulation, an experiment to see, using the data we have, what is going to happen next?
Yeah.
Every time you roll a die, you're rolling a single dice is giving you a simulation of what can happen when you roll dice. So if you roll it thousands of times, you'll have an idea of whether this is a fair dice or not.
Right.
Because you can count those things. Law of large numbers comes in again. Yeah, that's essentially what Monte Carlo simulation is, saying right now we have a bunch of information. How do we use that information to run a single simulation of what can happen next?
Okay.
And if you do that thousands and thousands of times, what you have done is thousands and thousands of Monte Carlo simulations. And as you're essentially running the future over and over again to get an idea of what are the range of options of what can happen and what is the probability of each of these options happening.
Right. Okay. And so aside from software development, where are some of the most common use cases, or what industries would Monte Carlo be used in?
Yeah, for those of you who have done any sort of financial planning or retirement planning, I am sure have seen the graphs that most financial planners or retirement planners do, which are essentially results of Monte Carlo simulations. They are running Monte Carlo to figure out how much money you will have by the time you retire.
Right.
They're running that future over and over again. I think it's called Project Management Happy Hour. I think that's what it's called. And they had someone there from the mining industry who was talking about how they do their project management running Monte Carlo to figure out what will happen. I mean, even something like drug trials could potentially be using Monte Carlo to figure out how likely it is that this will become this particular drug will work out. So
I see. So how about the new hot button topic of the world? How about AI, right? Which is really based on machine learning. Is it used there?
I'm not entirely sure. I mean, again, I have worked with data science quite a bit. It can definitely be used there. What I do see is what they're doing is, as they run their AI algorithms over and over again, they're collecting that data. And as you said, the machine is learning using that data how to do things better next.
Right.
And while that is not exactly Monte Carlo, that is exactly what we are trying to do using Monte Carlo. Can we do these things over and over again? And for AI engines, luckily we are doing it for them.
Right.
And can we do this thing over and over again and figure out what will happen next? Figure out how to execute something best next.
Right, using a probability. And so essentially, the machine learning process is a probabilistic approach, right? Because they don't know what's going to happen, and they're just trying to train the model. So cool, thank you. And are there different types of Monte Carlo methods out there that people
There absolutely are. There absolutely are. As I said, all we're doing in Monte Carlo is we are trying to simulate the future over and over again.
Okay.
Which means you have to have a model that takes all this data that we have collected and then use that model to figure out what will happen in the future. This is again connected to AI. All the machine learning models, all those AI models, what they're doing is they have collected all this data and they're figuring out, based on all this data, what is the probability of everything that can happen next. And for Monte Carlo, there could be multiple of these different models that you can use to figure out what happens next. A great example that we try for Agile folks, at least for software development folks, especially, you would notice that something like using December as a model for, say, February is not great, because people take a lot of vacation in December. There's Christmas, there's New Year's. People are just ending the year out. Also, December's 31 days, February has 28 days. Does that make sense?
Yeah.
Meanwhile, using the last 28 days of January might be a much better model for February. Those models can differ based on what your situation is.
I see. Gotcha. Okay, that's helpful. And there's different types of, maybe we can just walk through the very basic kind of algorithm of what's happening with a Monte Carlo, because like as you said, there's many different methods for it, and it could get very complex. But at its basics, right? Why don't you just kind of walk through? This happens, then this happens, then this happens.
Yeah.
The audience might have. Yeah.
So this is I'm going to walk through the most basic method, which I have found is also the best way in our industry to do it.
Okay.
So let's say you have 30 days worth of data.
Okay.
And you want to find out what will happen in the next 2 weeks. How much can we get done in the next 2 weeks? That's the question we're trying to answer.
Right.
I've got a 2-week sprint coming up. How many things can I get done? So you look at that 30 days of data and say, let me randomly select. I'm going to roll essentially a 30-sided die. I'm going to randomly select one day from the past 30 days and say that tomorrow, which is the day one of the 14 days that's coming up, is going to look like that random day I selected.
Okay.
So I select a random day. Let's say I got 2 things done that day. So I'm going to say, oh, I'm going to get 2 things done tomorrow.
Yep.
And then I'm going to try to figure out day after tomorrow. Randomly select another day from that 30-day list. And let's say I got nothing done that day. So 0 things. Okay, I'll get 0 things done on day 2. Keep doing that for all 14 days. And what we will have is one simulation that uses our past data to figure out, just by random selection, how much can we get done. If our future looks like the past, this is probably what we will get done. That's the one basic assumption we're making here, that the future looks like the past we're sampling from.
Sure.
So we've done this random sampling. We got one simulation. It'll give us one number as an answer. Turns out that is more of a deterministic answer. And as we said right at the beginning of the episode, we're looking for probabilistic answers.
Right.
Which means we have to do that particular process over and over again. And we do it 1,000 times, 5,000 times, 10,000 times. We'll get all these different answers, and we'll get an idea of how likely each answer is.
Yeah.
Because the number of times each answer comes up, that's how likely it is that, let's say a particular answer comes up 100 times, it's 100 divided by 10,000 times as likely as to happen.
Right.
So now, now we have a range of answers and the probability with each attached to each answer. So now we can make a more educated a forecast which contains the risk associated with each answer that we give people.
Right. Yeah. Thank you. That's a great explanation of how it works. So let's say that let's just walk them through an example. So let's say that you ran 1 million simulations of your past 30-day data, and you're trying to forecast how much a team can get done in the next 14 days. You ran 1 million simulations. The cool thing about modern day, right, is that we have very fast computers who can do this like in milliseconds pretty much. So, but anyway, so you ran 1 million simulations, and out of those million, 950,000 times a team could do at least 8 product backlog items, right?
Yeah.
And 850,000 times they could do at least 11. I'm just making these numbers up. And then 750,000 times team can do at least 14, right?
Yep.
So you're just presented, and then so on and so on. So as you can see, the lower the probability, the lower the percentile, right? The more stuff the team can actually do, because in those simulations, that's just how the simulations turned out. Okay. And that is applying the law of large numbers, like we talked about with the roulette wheel, to your software development work, basically. So it just presents you with an option. Well, we can say with a 95% certainty, we can get at least 8 things done, and an 85% certainty, we can get at least 11 things done, and so on, right? So which one should we plan for? Or which ones should we plan for? Because it doesn't always have to be a single answer, right? So for example, you could forecast externally, maybe you can use the 85th percentile, right? Internally, even 70%, again, if you use the lottery ticket example, if I told you had a 70% chance of hitting the lottery, you'd probably feel pretty good about that, right? So what I mean is, internally as a team, you can try for, like, hey, we're going to forecast the 85th percentile. We'll create a goal for that, for example. But we will try to do the 70% because we actually think it's fairly realistic too, right? And maybe we just treat the other 15, between the difference between 70 and 85 as more of a stretch goal or something like that, right? But we'll try because it is fairly likely 70%. And so that is just one way you can do it. You can also do a very basic, like, if let's say you're planning a release, and that release, you can think about, well, what the 95th percentile is. That would be the stuff we're very, very likely to get, right? So product owner, product manager, so-and-so, why don't you, it turns out that 95th percentile is 30 product backlog items, at least, right? So because of that, what are the most important 30 product backlog items to you, right? And then what are the next, right? So then let's say 85th percentile is 40. What are the next 10 most important to you, right? And you can kind of do a prioritization based on the probability. And because people love to prioritize, they might find that useful, right? So anyway, you can use it many, many different ways is what I'm saying. It's not a single answer, right? To your point, Prateek.
Yeah, and it changes the conversation from what are you going to get done to what risk are we taking on at different levels of commitment.
Yes. So, okay. So there are 3 basic principles of forecasting, right? The first one is to think probabilistically and not deterministically, which we've been talking about. And the second one is to update your forecast continuously. Why is that so important? Can we walk through an example of why that would be needed in software development?
Yeah, let's start with the hurricane example and then come to it, because I loved the hurricane example, the hurricane forecasting example.
Yeah.
Because what they do is, and those of you who live in a hurricane zone, this. What they do is every 3 to 5 hours, when there's an active hurricane, they send planes out. They drop these things. They dropped probes into the hurricane, get new data, and reforecast based on it.
Wow. Okay, that's pretty cool.
And there are these pilots who fly these hurricane hunters, which sounds like just an amazing job and amazingly dangerous job.
Sure.
They fly over the hurricanes and drop these probes into them. The reason they do that is because they need to issue these warnings and these watches so that people can evacuate if they need to. I mean, this is a matter of life and death.
Right.
If people are in a hard part of a hurricane and they live in homes that are right next to the ocean or that are not hurricane proof, essentially, they need to evacuate. And those warnings and those watches are life saving, and they're doing this every 3 to 5 hours. Now that we've talked about something very serious, we want to talk about something a lot less serious, which is software projects.
Right.
We should be taking the same approach as we get things done, as we add scope or remove scope, or as these days progress and we have fewer days available. We should be running these forecasts over and over again to see if that risk profile has changed.
Yeah.
And what action, most importantly, what actions do we need to take? Do we need to cut even more scope? Can we add scope? Do we need to God forbid, work nights and weekends.
Right.
Yeah,
Right.
we could get all. Can we move the date? We can get
Right.
information on how risk has changed, and use that to make those decisions. And I'm sure Troy, you do too, but we often get pushback on this stuff because they're like, well, people need a date.
Right.
Like, I get that. I get people need a
Yeah.
date, but if probabilistic forecasting can work for something that's life and death, like hurricane forecasting,
Yeah.
I'm pretty sure it can work for software projects.
Right. Gotcha. Yeah. And if it can work for your 401k, right? And it can
Yeah.
work for I'm sure it can work for us too, right? And you wouldn't want, I'm assuming you wouldn't want the people handling your 401k to use a deterministic approach to it, right? I'm sure you'd want them to think in terms of risk, right? And that's exactly what we're talking about too. And if you think about it, right, companies spend, I mean, I know it's not the same as a life or death for a hurricane. I get that, but companies are spending millions and millions of dollars on software development projects, right? So, and our jobs and careers and everything else are wrapped up in that. And so we're trying to treat it with the same level of importance as we treat other industries. So that's really the gist of it, and trying to make it actionable. All right, last topic I have for you, Prateek. Well, so what about standard deviation, right? Why wouldn't we just use that for and figure out a probability from standard deviation?
Yeah, there are multiple problems with it. There's a great book by Dr. Sam Savage called The Flaw of Averages, and he gets into a lot of this stuff. The summary of the book is plans based on average fail on average, but then once you get past that part of the book, he talks a lot about standard deviations and shapes and probabilistic distributions, and he calls them steam error statistics.
Wow. Okay.
He calls them that because these distributions and these statistical measures were a hack when we did not have the ability to store and process actual data. We were able to guess at what the shape of the data is, or what it would look like by using averages, standard deviations, variances, a standard distribution, a normal distribution, Weibull distribution, whatever it is. But we are in an era where we have more data than we know what to do with.
Right.
When we have real data, we should not be relying on steam error statistics and shortcuts. Use the real actual data to make your decisions, as opposed to using these hacks from the past.
Wow. Okay. So what about some people will use, inside of a Monte Carlo, they will use standard deviation as part of it. So is there an appropriate time to use it, I guess, or what would the use case for that be?
Yeah, there is this is where we're gonna geek out quite a bit, and this is now you're all getting math homework. There's a thing called the central limit theorem. And in statistics, the central limit theorem, what it says is, when you sample randomly from distributions, from actual data, not from distribution, but from actual data, you will end up with what's called a normal distribution, not a standard normal distribution, but a normal distribution.
Okay.
When you're randomly sampling and creating a histogram of results, you'll end up with a normal distribution. There are some assumptions behind the central limit theorem, which are important to know. One of which is that the data is identically and independently distributed. Now, it turns out most data in our world is not independent and not identically distributed.
Right.
If you all remember, when we talked about Monte Carlo, we were talking about sampling. We were talking about randomly sampling. When you do that, the results of a Monte Carlo distribution histogram, the result histogram for Monte Carlo will end up looking like a normal distribution. If your data was independent of each other, which is very unlikely in a situation, and was identically distributed,
right,
you will actually get a normal distribution.
Okay.
According to the central limit theorem, you will actually get a normal distribution. And you can, at that point, use things like the average result and the standard deviation.
Hmm.
But the problem is, in many, many cases, you don't get a normal distribution.
Okay.
But the percentile approach that Troy, you were talking about earlier, 95% got done here, 85% here, 75%, that works in all distributions. It does not have to be a normal distribution for that approach to work.
I see. Is
So why not use that simpler approach? Yeah.
is there a computational advantage to using the standard deviation approach in Monte Carlo? Meaning, yeah, is there a computational advantage? Meaning it's just faster to do and requires less computational power to do.
It actually
Hmm.
takes more computational power to calculate a standard deviation.
Okay. Okay.
Because
All right.
Because for calculating a standard deviation, first thing you need to do is you need to find the average.
Right.
Then you need to find out how far each result is from the average.
Hmm.
Then you need to square that. Take the square
Okay.
root. I mean, you have to. Those are all the steps that go into calculating a standard deviation.
Sure.
The steps that go into counting a percentile is count the number of things that happened and divided by the total number of things. That's it. That's your
Right.
percentile.
Okay.
So it is so much cheaper I don't even know why we're worried about CPU cycles today,
Okay.
but it is
Right.
so much easier and cheaper to calculate a percentile than it is to calculate a standard deviation.
Gotcha. I was just curious. I'm trying to
Yeah.
think of the different use cases for different types of the way you do it.
Yeah. The thing with the standard deviation is, if your data, one, you need to know how your data is distributed, or your results are distributed. But
Right.
if your results do end up distributed in a along a normal curve, then sure, you can use it. I
Right.
just believe for most software projects, or for any project that has dependencies, and that different types of work are not identically distributed,
Hmm.
it does not end up as a normal distribution.
Gotcha. Gotcha. Makes sense. Okay. Well, thanks, Prateek. So I think we're coming up on time. We didn't get too we didn't get into too much math. Only a little bit at the end, right? So
Yeah.
that's okay. All right. So if people wanted to, let's just wrap it up. If people wanted to learn more about probabilistic forecasting in Monte Carlo, and maybe even to apply it to their own work, how could they do that?
Well, there are the place I will send people. The first place I will send people is, if you go to the prokanban.org website,
Mhm.
you will find, as Troy had mentioned before, applying metrics for predictability classes. That the trainings offered by multiple trainers. There is also a lot of self-study material that you can find on the prokanban.org website. That's the first place I would send people. Um, if you want to get really deep into this stuff, go read the National Hurricane Center literature.
Okay.
They have a lot of fun stuff. Look up the Fermiac by Enrico Fermi. That's from the Manhattan Project.
Mhm.
If you want to really go deep into the stuff, there are a lot of resources. But the first place I would send people is go to the prokanban.org website and look at the upcoming applying metrics for predictability classes.
Yeah. So the cool thing about I mean, I am a trainer for procommon.org, so I should just make sure that everyone knows that. But the cool thing about that is there are a ton of resources which are free, you don't have to pay for a class to learn, right? And obviously it helps to have a trainer explain things to you and walk you through like how to do things, like showing you. But if you just say, you know what, I'm good enough to learn on my own and I don't need a trainer, you can do that, right? And you can just go to the website and look at the resources and go from there. You know, Dan Vicanti has a great book called When Will It Be Done, which is all about probabilistic forecasting in Monte Carlo. And so he that came out in maybe 2019 or ish or something.
Yeah, 18 or 19.
Yeah. And I read it when it first came out. I read it on LeanPub before it was published, I think, back then. And you know, that it was, for me, it was very helpful. And so that could also be a great place to start. And I'm sure that's on the resources list. I'm guessing that. So.
Absolutely.
So thank you very much, Prateek. So I will put a link to obviously procommon.org, that resources. I will also put a link to your Drunk Agile YouTube channel. There are I was watching your latest video yesterday actually about variability.
Mm-hmm.
And so I'm thinking there's 70-ish episodes or something
like that. Yeah.
So so go to his YouTube channel. Himself and Dan, they have a great YouTube channel, and where they take viewer questions, and you may get your questions answered potentially in an episode as well. So thank you, Prateek. This is great.
No, thanks for having me. And I'm so glad we got to talk about. I think the most important thing we got to talk about was just for your listeners, the fact that you can do all these forecasts, but you have to take action on them, understand the risk behind stuff, and again, to quote Dan, these forecasts are useless if you don't take action based on them.
Yep, makes sense. Thank you.
Hey, it's Chris Mitchell. After 10 years with no dog, we got Walter. I bring him to work with me a couple days a week, but on the days when he's not here, he goes to Ridgeside Canine for puppy daycare. Walter absolutely loves it there, and I know he's in great hands. Clean, spacious, happy. We even see pictures on Facebook of what he's up to. I love that you can have him train your dog while your dog's with him. I can't recommend them enough. Ridgeside Canine Training Facility and Aquatic Center on Gateway Drive in Winchester. That's RidgesideCanineWinchester.com.